Welcome back. This is CS 1401, video 2.2, and today in this video I'll be discussing variables and states. So we've been looking in the last video at a pseudocode algorithm for calculating the body mass index. And we can use that pseudocode algorithm to look a little more precisely at the idea of a variable. In fact, our algorithm already has variables in it. So let's first look at the statement get weight. Weight is a symbol, of course, and what we really mean by get weight is get a number from the user somehow and store it in a location that has the identity designated by weight. Put it another way, weight is a variable that has the value of the user's weight. Height is another variable. It's also going to hold a number, and that will be the user's height. Basically, the symbol height is a way of referring to the value that represents the user's height. Now, there's a third variable here too, and that's BMI, which you and I know stands for body mass index. And in the third statement in our pseudocode algorithm, which is called an assignment statement, we use the weight and height to calculate the body mass index. So we do the calculation, and then the assignment operator basically stores the value that we calculate in a location whose name is BMI. In other words, BMI is a variable that's going to hold the value of that calculation. And then when we want to give the user back the value, we can refer to that location, we can give the variable name, and that says is give the user the numerical value which is stored in the location that has the label, the variable name BMI. So we already have variables in our pseudocode. Weight, height, and BMI are named places to store values. These are variables. Now, the pseudocode statement BMI is weight divided by height times 703 is, as I said, an assignment statement. What an assignment statement does is when it's executed, is evaluates the expression on the right side of the assignment operator. And in my version of pseudocode here, the assignment operator is the left pointing arrow. So it evaluates that expression, and then what it does is it stores the result of the evaluation in the variable on the left side of the assignment operator. Now, there's some other operators in that expression. Those are the slash and the asterisk symbols. Those are what are called arithmetic operators, and the slash represents divide, and the asterisk represents multiply. So weight and height are variables, and when they're on the right side of the assignment statement, this means get the value that's stored in the variable and then apply the operators to them. BMI is also a variable, but it's on the left side of the assignment statement, and so what that means is take the value that's calculated on the right side and store it in the variable called BMI. Here's another example, tracking fluid intake. So suppose that I know that I'll have 5 drinks of water a day. Then I can write a pseudocode algorithm to determine how much water I've drunk in total over the day. So I'm going to call my algorithm calculate fluid intake. And it's got a number of steps. I will get the value of drink 1. And what that means basically is from the user somehow, either through the keyboard or reading somehow, we'll get a number and we'll store it in a variable called drink 1. And I'll do exactly the same thing for drink 2 and drink 3, drink 4, and drink 5. Now, the key step is the next one. It's our assignment statement. So I add on the right side of the assignment statement the values in drink 1, drink 2, drink 3, drink 4, and drink 5. In other words, by saying drink 1, that variable name on the right side of the expression means use the value that's identified with or stored in the variable drink 1, add it to the value that's stored in the variable drink 2, and so forth. So we add all those up, and then because we have an assignment statement, it stores that total in a variable called total fluids, and then I can, at the end, give to the user that value which is stored in total fluids, which is going to be all the sum of the fluids I've drunk during the day. Now, algorithms typically are more complex than this, but this is designed to let you see at least a simple algorithm. And one of the things that computer scientists do is try to make sure, to ensure that an algorithm will work. And we do that by tracing an algorithm. So we do this on paper or in a spreadsheet, and basically we want to trace our algorithm before we write the computer code so that we know the algorithm is correct before we start translating it into something the computer is going to execute. It's much easier to find problems with logic in the pseudocode stage than it is later on because we don't know where the problem occurred. So tracing involves executing the sequence of instructions with a sample set of values, computing the value of each variable after each instruction is executed. So there are 3 basic steps in tracing. Number 1, write down all the instructions in the algorithm and we'll number each instruction. We'll make a table. The first column in the table, other than the number of the instruction, is the instruction that's been executed. And the subsequent columns, that is all the columns to the right of the instruction, list all the variables of the algorithm. And then step 3 is filling out the table, completing the table. Each column of the table represents a variable. We start at the first line of the algorithm. We identify what will happen to each variable as that instruction is executed. And in fact, each line is a state. So it represents the point, what's going on in the computation at that point. And as values change, we'll change any values that the instructions changes, and we'll leave all the other columns blank. So let's try tracing an algorithm, and as an example, we'll use my calculate fluid intake example. So here's the title of the algorithm, which is calculate fluid intake. There are columns for the step number, the step, which is the instruction, and then I've listed all the variables across on the right. So the first step involves getting drink 1. So let's say that my first drink was 12 fluid ounces. Now there's only a value for drink 1 because drink 2 and through drink 5 and total fluids, they all remain undefined. There are just no values for those. Let's say my second drink was 17 ounces, and so now I have values for drink 1 and drink 2, and so forth all the way through drink 5, which turned out to be 5 ounces when I took my pills at night. So now we get to step 6. And step 6 is our assignment statement. So we know that the right side variables get added up, and that total, which turns out to be 66, is put in the variable called total fluids, and now total fluids has the value 66. Now we're going to execute finally the step 7, which is give total fluids. All that does is retrieve the value in total fluids, which is 66, and give that back to the user. There's no change in the values, but we've traced the algorithm. So as I said, at each step of the algorithm in the table, there's a new state. The state is the set of values of all the variables at that step. And the state of the computation can determine what step is taken next, because we'll look at more complex programs and algorithms in a little bit, and we can choose to do different things based on what the values of different variables are. Well, for example, maybe we can determine the meaning of the body mass index. So we'll define an algorithm. Let's write an algorithm called determine BMI meaning. So what we'll do is we'll get the body mass index, and we already know how to do that. And so we'll look at the rest of the algorithm. So my idea is that following the recommendations of the National Institutes of Health, if the body mass index is less than 18, then a variable called BMI meaning will have as its value a string. That is, it's a set of characters, alphabetic characters, that hold the word underweight. If it's not less than 18, so that's else, if the body mass index is less than 24, then we'll put the character string normal weight in the variable BMI meaning. And if that's not true, else, we'll assign the character string overweight to the variable BMI meaning. Then in my algorithm, we give BMI meaning, and just to provide some encouragement for those of us who are too skinny, if BMI meaning equals underweight, and I've got a double equal sign there to indicate test for equality, then give the string, hey, start eating, to the user. What's interesting about this algorithm is that the assignment into BMI meaning depends on the value of BMI, so that the table, when you do the trace, will have to look at the value of the variable BMI in order to understand what should go into the variable BMI meaning. Now, the good news is that my BMI, as we calculated it in the last class, is 23.5. So, hey, I'm okay. And on that happy note, I'll say so long for today, and look forward to talking with you next time.